I know this next speaker from the scenic community, but his work has spanned everything from embedded systems to game design and civil involvement. Let's give it up for Jason.
Okay, thank you. Welcome to my talk. I'll be talking and giving some practical tips for Elixir and Erlang engineers about testing. But first, a little bit about me. I've been using Elixir since about 2016. I maintain a whole different range of libraries. I'm a senior software engineer at Felt, where we're making the best online mapping software, and you can follow me on Mastodon. So why even talk about testing? Well, I think that testing is a crucial part of writing and especially maintaining software over a longer period of time. And I personally wish that there were a little bit more talks talking about testing in practice and giving practical tips. So what does the roadmap look like for today? We're going to talk about writing tests, about running them, cover some spicy entry patterns, and follow up with some library recommendations. So a lot of this talk is driven by my personal opinions that I developed over my career. I hope that they are useful for you in your own testing. So let's talk about writing tests. My first tip is to write tests to fail, which sounds counterintuitive, I know, but bear with me for a second. So consider this test. It's a lovely test. You're creating a user from a user factory, you prepare some adders, you get a change set back, and the core of the test is that you're asserting that this change set is valid. But what happens when you run this test and it fails? Let's see what happens. So the error you get back is expected truthy, got false. The change set's not valid. So if you get this error in CI, it's just not helpful. You have to pull down the code, maybe update the test before you can get useful feedback. So instead, when you're writing the test, let's try and rewrite it. So you can rewrite it in a way where it'll give you useful failure or useful feedback on failure. So most of the test is the same, those first 3 lines of setup. But where it's different is now we're using this errors on helper that comes in by default in Phoenix projects, but it's also a very easy wrapper to write yourself. And now when we run our test, we get a much nicer error where we can see, OK, the error now is that the email can't be blank. Maybe we messed up something in our factories or whatever. And if you see like 10 failures with the same error, you know you're really dealing with one set of failures rather than a whole bunch. My next tip is to always put this is a little bit more opinionated, but always put your expected values on the right side of assertions. And the way that looks is you have the assert, and you have actual on the left, and then expected on the right. And actual is what you're getting by calling your code under test. And you have, like in this example, assert actual equals 4. I like this because it's a consistent pattern, and that helps readability of tests because you know what to expect when you're reading them, or even when you're reading test output, you always know which is the expected, which is the actual. And it also helps you to be able to write or to read your test in a logical flow from top to bottom and left to right. So here's an example of what I would consider a bad test in this vein. So first, you are doing your setup. You're creating your post from the factory. And that's all good. But then you have to jump forward when you're reading this to go to the end of the test to see what the actual code you're calling is doing. And then you jump backwards to whatever this expectations you're setting on it. And this isn't too bad because it's only a few lines, so I could make it easy for the slide. But I've seen examples of this where there's like 10 lines of pattern matches. And it just becomes very hard to read. So what I would do instead is to put the assertions on the right side. And so in this test, it might look like this, where you still have the same setup initially, but now you're calling your actual code under test. And then you have your assertion here with all the values. And if you've done a decent amount of Elixir development, you may notice a problem that might be coming right now, which is when you're just getting started, sure, maybe your post module only has a few attributes like this, but if it has 15 attributes and some of them have non-nil default values, then your test is going to start getting messy again. And so what I would recommend in that case is a library that I really like to use by Matt Trudell called Machete. And so testing with Machete, you still have the same setup, and then you can call your function under test, and rather than a normal assert, you have this special like squiggly arrow assert, and you can use a bunch of these different matcher functions. So in this case, you're using a matcher called superset that allows you to provide only the attributes in the map that you're interested in matching on, and you can ignore the rest while keeping everything still on the right side of your assertion. And it can do some other assertions also. One of the nice things is that you don't need intermediate values for pattern matching, like that post ID I had in that first example. And the matches support many different attributes, such as min and max on your integer. You can provide a regex match on your string directly in line. And there's even a JSON helper, so you don't have to do a whole JSON encode, decode dance. My next tip is to use async tests. Why is that? One of the main reasons is so your test suite is able to execute faster, because we're only getting to have more and more cores over time. And also, as a sort of side benefit, it helps you to understand your system more deeply, because you have to understand all the different side effects and race conditions and global state that you have. And I'll be honest, I think it's kind of fun. So what prevents writing async tests? There's a number of things. One easy one to address is just forgetting to even add async true in the first place. But the larger thing really is anything that modifies global state will make it so you're not able to write async tests. And that there's a number of things in Elixir programs. Application environment is one, which is built on top of ETS, but you also have your database, registering processes that caught me out a few times, and there's many others as well. Before I dive into async tests, I want to introduce a library that I use for testing, which is called Bypass. And it's a library that allows you to stand up a little mini mock HTTP server and set expectations on it specific to that test. So the way it works is you start your Bypass server, which creates a little mini web server inside your test. And then you set your expectations on it. So when a request is received by the Bypass server, you say, OK, I want to return, say, a 429. And then you call your code under test, and you pass it that bypass port, which is where that bypass server is running. And that's how the test gets hooked up to the specific bypass server for this specific test. So how can we now test this little bit of code using a bypass server? So we have our function. It receives a path and body of where we're going to send some HTTP request to. But it's getting the actual base URL, which is where we need to get that bypass port into from the application environment. So one thing we could do is use application.putenv, but that would mean that our test is now not async safe because application environment is part of your global state. So what I would recommend here, or actually first, one common recommendation is to pass that base URL to your function as an argument. And when that base URL is passed, then you use it. Otherwise, you're falling back to whatever is in your application environment. So that works well. But what if this function is 10 levels deep in your code? If you have to pass that base URL through 10 levels of your functions, that just becomes very messy, especially if you have other variables you're also trying to pass. So a library that I recommend for this use is called process tree. And process tree is specifically made to avoid global state in Elixir applications, and I think it's very well suited for testing. And the way it works is basically mimicking the application environment. So it looks up values in your process dictionary of the current process, and that works extremely well for testing because every test runs in a separate process. So when one test finishes, that process dies, and a new process is spun up for the next test. And if process tree doesn't find the value it's looking for in the process dictionary of whatever the current process is, it'll look it up in any ancestors and any callers. So if you're spawning a task or anything like that, process tree will be able to find the value that you've injected into your test in 95% of the cases, depending on your code. So how would this function look like with process tree? Well, rather than doing an application.getEnv in your code, instead you'll be doing a process tree.get, and you're still looking for the base URL. You still have some sort of default that you're providing, which I'm not showing, but it could be from application environment or it could be from wherever. And then inside your test, you call your bypass open, and then you use process.put to inject that value that you're interested in into the process dictionary of the test process. And that's how your code gets that bypass port. And then you call your function, and even if that function is nested 10 levels deep, it's able to still get that value from the process dictionary. And if you don't want to, if like seeing that process tree.get directly in your production code feels a little bit off, you can also create a little wrapper around it. Here's a simple one in 12 lines or so, where in the test, it's only wrapping it in the test environment. Otherwise, in production, you're only getting the value directly from the application environment. OK, next tip. I recommend verifying. One thing I've learned is that you're able to verify tests by changing code. So this is a thought experiment. So if you have your code, and then you modify your code, maybe you delete some really important part of the test or your code, and then you run your test suite, does your test suite fail? It may not. And if it doesn't, that means you're missing a test. And this can be especially helpful sometimes if you're reviewing a PR and you think that some of the code may not actually be fully tested in there. And this is formalized in an approach called mutation testing. And Devin S. has written a nice blog series about it, as well as created a library. And thank you to Jeffrey for this tip. Another tip is to not depend on values from factories. So whenever you're writing tests, I think you shouldn't actually depend on any of the values from the factories themselves, like any of the default names or properties, because then if you make any changes to the factory, you suddenly have a whole bunch of test breakages that are not really related to the code that you're testing. So here's an example of a bad test here. You are creating a user, and you're providing, OK, the age is 25, and then you're updating it to age 30, and then in your assertion, suddenly you're asserting that the name is Joe. Like, where did that come from? It came from the factory, which means if you change the default name of the factory, this test will break. So this test should not rely on that. So instead, I would rewrite the test to only assert on the updated users on the age and not the other properties. And one library you can introduce that will actually help catch this automatically for you is the faker library, because that will give you default values or random values for every property. So rather than Joe, it would be a random name every single time you run a test. Also, did you know that XUnit has a built-in temp directory feature? So if you tag your test with temp directory, then you'll get a temp directory specific for that test, and it'll get cleared out before every test, and you don't even need to bring in a library. Yeah, thank you to Lars for this tip. You can also, this is a little bit more an advanced tip, but if you have some properties that you set in some of your factories and you want to set them uniquely for each test that you have, you can set them like this. So you have tag admin true, and you can say, OK, given that I'm now using an admin, what should admins be allowed to do? In this case, they are allowed to delete posts, and then users that are not admins are not allowed to delete posts. And the way that works is in your setup block, you look at the test context that the setup receives, and you check if that admin tag was passed. And if it is, you create the user in a way that is an admin. And if not, then you create them as a non-admin. But my recommendation here is to only use this very sparingly and only for the primary entity, because otherwise, your setup blocks start to grow very unwieldy and large. I've also noticed that when the setup blocks start to grow so large, they start to have a sort of gravitational pull where instead of like creating a new describe block and copying over the important parts of the setup, developers will just start to adding more and more to the setup block, and they just grow larger and larger, and you have more overhead for each of your tests. Another tip that I picked up from Martin Fowler is to use a given, when, then style of comments for your tests. So you have given, which we're saying what the specific scenario is that you're setting up, and then you have your setup code, and then you have a when comment, and you say, OK, what the specific action you're doing is, and then you have then, and you say what the assertions are after the test. You might be looking at this thinking, oh, this seems very verbose, Jason. Why are you doing this? And it is for this. I wouldn't do this if it's only like this 5 lines of code. But if you have like 30 or 100 lines of code, then I think this becomes very useful. But even if it is a short amount of code, I would still do a similar pattern, but I would just not actually show the comments. Instead, I would just ensure that there is a full blank line in between each of these given, when, and then sections. OK, now let's talk about running the tests. My first tip here is to use a library by Louis Pilford called mix test watch, where you run it mix test watch, and you provide like the file name and maybe the line number of the test. And then in your editor, whenever you change your source code, the test will automatically rerun. You don't have to switch to your terminal and rerun your tests. So very worthwhile, very simple to adopt. Another library and technique that I wish was more common is this XUnit span by Anantha Kumaran. And when you run this, it actually runs an XUnit formatter, and it actually gives you a trace that you can then load into Chrome DevTools so you can visualize the async or non-asyncness of your tests. So in this example, you see that this test suite is very non-asynchronous because the first 4 test processes finish in about 3 seconds, and the last one doesn't finish until about 22 seconds in. Also, I would recommend spending the 30 minutes or less to actually learn how to run tests directly from your editor. There's a bunch of different extensions for this, and it just saves a lot of time over instead of having to like copy the file name and the line number for the test you want to run every time, into your terminal. Instead, you can just hit a keyboard shortcut and you can run the test under your cursor or maybe the test for the whole file. And did you know that there's actually 2 different ways to run a single test? The common one that you might be familiar with is to run it by line number. So if you run mixed test and you provide the path to the file and then colon and the line number, so in this case, colon 12, this will run only the test that is on line 12. Or if it's a describe block, it'll run everything in the describe block. But there's also another way. You can run a single test by test name. So if your test looks like this, admins can delete others' posts, then if you run mixed test -- only, and you have test : test, admins can delete others' posts. Only that single test will be rerun. It doesn't matter if you've deleted a whole setup block and moved your test up and down, it'll still be rerun. And the way this works is that first test with the colon is the tag that we're filtering on, and the second is the test name. So the actual test name includes test. And if it has a wallaby test, then it'll be feature instead of test. OK. Let's talk about anti-patterns. And this is definitely even more opinionated for emphasis. OK, my first anti-pattern is chasing 100% test coverage. I think this just encourages all of the wrong behaviors. You aim to create test coverage instead of actually aiming to write effective tests. And your test suite just ends up becoming very brittle over time. And if you refactor any of your code, you end up breaking a bunch of tests that are testing implementation details when they should be testing actual business logic. So instead, what I'd recommend is aim for maybe 80% test coverage, and then focus on writing effective tests. Another anti-pattern I've seen is 1 assertion per test. So that's when instead of having tests that have 2 or 3, it has only exactly 1 assertion. And so for a Phoenix example, it might look like this. You're testing the logout, and you have 3 separate tests testing logout. One testing that the user has been redirected, another testing that the token has been deleted from the session, and a third that's checking that the user has seen a flash message. So rather than writing those 3 separate tests, instead I would just write a single test that's testing all 3 behaviors that we care about. And that way you don't have to pay for the overhead of having to do all that setup each time. And I think it's just a lot more compact and more clear. And another anti-pattern, in my opinion, is using any mech-based libraries. And the reason for that is because mech works by replacing modules wholesale in the beam. And modules are also another source of global state in the beam. And that means that using mech-based libraries are not async friendly. And also, and a number of times I've seen replacing modules, especially any that are in the standard library, creates some very hard to track down bugs in the test suite. And I've wasted over an hour on this multiple times. And it's just not fun because it creates invalid data. OK, let's talk about some libraries. Here's the libraries I previously mentioned, if you want to see them all at once. And the first library here is Parameterized Test by Tyler Young, who's one of my former coworkers. And this allows you to create tests from Markdown or JSON tables, basically truth tables. So rather than writing 3 separate tests like this, we're checking, OK, editors are able to view and edit. Viewers are able to view but not edit. And anonymous viewers cannot view or edit. You can just instead have a single test saying you're verifying what permissions or what users are able to do with their permissions. And you can see visually, OK, if they're an editor, they're able to view, and they are able to edit. And Parameterized Test will take this actual Markdown table, and it will generate 3 tests for here, 1 for each line. And it'll pass those into your test function, and then you can plug it in your various factories and some code. So for a certain class of tests, this is just very, very useful. Another library that I don't think is used enough is called Neem by Zachary Allen. And it is a snapshot testing library. So as developers, a lot of times we're writing code, and then when it comes time to update some of our code, we update the code, and then we get a bunch of broken tests. We find all those tests, and then we fix those tests to match what the new code is. And Neem basically automates this for you. So rather than writing a full assertion to start, you instead write this auto assert, and you call whatever function it is. And then when you run your tests, you'll see a prompt like this. And Neem will say, OK, do you want to update your assertion to this, what this function is returning, which is my awesome value, so cool. And it'll actually give you a few different options. When you find one you like, you press Y and press Enter. And then Neem will actually rewrite the source code of your test to have that new assertion without you having to do any extra work. And then if you update your code, and now instead of returning so cool, it's returning so rad, your test suite will fail. But then if you want to update it, it's as simple as just pressing yes on that prompt again. OK, and my final library/technique is called property-based testing. I would call it a fancy testing technique. And rather than writing individual test cases, which is what I would call example-based tests, like what I've been showing here, instead, with property-based testing, you generate a bunch of random test data and use it to verify specific code properties on your tests. So it's very helpful, but the hard part is finding code that's applicable for it and trying to figure out what properties you want to test on your code. But if you do want to use it, then you can use, in Erlang, you could probably use proper, and Elixir, you have a library called streamdata. And this is what a property would look like in streamdata, where you're checking, OK, for any list of integers, I want to assert that if I reverse it twice, then I'm getting back that same original list. OK, and thank you. I hope that was useful. And are there any questions? I think we have time for questions.
Yeah, we have a couple minutes.
OK.
I didn't see anything in the app, but does anyone have any questions in here? One of the questions that did come in was whether you recommend testing private functions or not, and if so, how you do that.
I generally haven't tested private functions, but I can definitely see a need to based on what the code is. But I would sometimes just make them public and test them that way. Although I think there are a couple libraries that do facilitate that, and I think that's fine to use in your code base.
Cool. Well, thank you so much, Jason. If anyone else has questions, feel free to toss them in the app, and he'll see them later.
Okay. Thank you.